AC cable sizing calculation. Calculating the correct size for AC cables is crucial to ensure safe and efficient operation. Here's a step-by-step guide to help you with the calculation. Steps for AC cable sizing calculation. 1. Determine load requirements. Identify the power, in watts, and the voltage of the load. 2. Calculate load current. Use the formula, I equals P3 times V times power factor equals \frac P \sqrt 3, times V times text power factor, where 2 is the current, PP is the power, VV is the voltage, and the power factor is typically 0.8 for three-phase systems. 1. Consider cable length. Measure the distance from the power source to the load. 2. Allowable voltage drop. Determine the maximum allowable voltage drop, usually 3 to 5% of the supply voltage. 3. Select cable material. Choose the conductor material, for example, copper or aluminum, and check its resistivity. 4. Calculate voltage drop. Use the formula, drop equals 2 times L times I times R 1000 V _ text drop equals \frac 2 times L times I times R 1000, where LL is the cable length in meters, 2 is the current, and RR is the resistivity of the conductor material. 3. 1. Check ampacity. Ensure the cable can handle the current without overheating. 1. Refer to ampacity tables for the selected cable material and installation conditions. 2. Consider derating factors. Adjust for factors like ambient temperature, soil conditions, and cable burial depth. 3. Final selection. Choose the cable size that meets the voltage drop and ampacity requirements. Example calculation. Assume you have a three-phase load with the following details: power, 80 kilowatts, voltage, 415 V, power factor, 0.8, cable length, 200 meters, allowable voltage drop, 5%. 1. Calculate load current. I equals 80,0003 times 415 times 0.8139. I equals \frac 80,000 \sqrt 3 times 415 times 0.8 approx 139a. 1. Calculate voltage drop. Drop equals 2 times 200 times 139 times 0.017510019.87 VV _ text drop equals \frac 2 times 200 times 139 times 0.01751,000 approx 19.87 V. 1. Check allowable voltage drop. Allowable voltage drop equals 415 times 0.05 equals 20.75 volts \text allowable voltage drop equals 415 times 0.05 equals 20.75 V. Since the calculated voltage drop, 19.87 V, is within the allowable limit, 20.75 V, the cable size is acceptable.